In the given energy level diagram, find A. The largest possible energy emission in given condition. B. The longest wavelength of emitted photon. C. From which atom the energy levels have been taken. So we have this energy level diagram given in the question, and we can see for n equals 1, the energy E1 equals minus 122.4 electron volt, and for n equals 2, the energy E2 equals minus 30.6 electron volt, and for n equals 3, energy E3 equals minus 13.6 electron volt. So we have this. So let us discuss solution of A. Okay, so we are asked to find the largest possible energy. So I'm writing, we are asked to find maximum or largest possible energy, okay, clear, of the emitted photon, clear, and we know energy of photon, okay, so we know energy of photon emitted when there is transition, okay, when there is transition from higher level to lower level is, okay, given by delta E equals h, that is Planck's constant, times frequency. So we have this, and we know, okay, we have this relation, okay, speed, we know this, okay, speed V equals F, that is frequency times wavelength. So we have this, and for photon, okay, for photon we have V equals C, okay, therefore we can write C equals F times lambda. So we have this, so this is to be noted, okay, we have this relation. Now we are going to sorry, put the value of frequency in term of C, that is speed of photon, okay, in this equation. So we can write delta E equals h time frequency, and frequency is C by lambda. So we have this, so we can write delta E equals hc by lambda. So we have this. Now energy to be maximum, okay, for energy to be maximum from this relation, okay, wavelength must be minimum, okay, wavelength must be minimum. So we need to understand this, okay, so we need to find the maximum energy, okay, of emission. Now we can see maximum energy corresponds to the transition, okay, from n equals 3 to n equals 1, okay. So let me write in this way, this transition corresponds to maximum energy. So in this case the wavelength is minimum, therefore we can write, okay, therefore we can write delta E max, okay, so this equals E3 minus E1, because we know the difference in energy corresponds to n equals 3 and n equals 1 is maximum. Okay, so let us put the value. E3 is minus 13.6 electron volt minus, and E1 is minus 122.4 electron volt. So maximum energy delta E max equals, we get this, minus 13.6 electron volt plus 122.4 electron volt, and on simplification we get delta E max equals, so we have 108.8 electron volt. So we are getting this, that is the largest possible energy, and we can change this in joule also. Okay, delta E max equals 108.8, and we know 1 electron volt, okay, equals 1.6 times 10 power minus 19 joule. So we have this. So on simplification we get maximum energy or largest energy in joule is 1.74. okay, so we have this 1.74 times 10 power minus 17 joule. Okay, so after doing the calculation we get this. So we have this result. Okay, so we have this, and as I said earlier, this corresponds to, or this corresponds to the largest energy, largest possible energy. So we have this. So this is to be noted. Okay, so we have this. Now let us go for solution of B. Okay, so we are going to discuss solution for B. Solution of B. So we are asked to find the longest wavelength. Okay, we are asked to find the longest wavelength. Again we use this equation. Okay, delta E equals h c by lambda, and we know we are asked to find the longest wavelength. So longest wavelength means maximum wavelength. Okay, so we are asked to find the maximum wavelength. So to find maximum wavelength, that is lambda equals lambda max. Okay, so we have this. So we are asked to find maximum wavelength. Okay, so we need to note this. Now if wavelength is maximum, okay, then energy is minimum. So we need to note this. Okay, for lambda equals lambda max, okay, energy is minimum, that is delta E is minimum. So we need to note this. Now when we look into this energy level diagram, okay, the minimum energy corresponds to, okay, we can see we have a energy, okay, for n equals 1, n equals 2, n equals 3. Now when we have transition, okay, when we have transition from n equals 3, okay, when we have transition from n equals 3 to n equals 2, okay, then this transition gives us minimum energy. So this gives minimum energy or maximum wavelength. So this is to be noted. Okay, so what we do now, okay, is that to find minimum energy, okay? To find minimum energy, we consider transition. So I'm writing the transition, okay? The transition from n equals 3 to n equals 2 level, okay, gives photon, okay, of minimum energy, or it gives photon of maximum, okay, this is to be noted, maximum wavelength. So we have this. Therefore, we can write E3 minus E2. So this corresponds to the minimum energy, okay? And this equals, we have h, that is Planck's constant, times speed of light, okay, divided by, we have maximum wavelength. So we have this. Clear? So we are asked to find the maximum wavelength. So for that, okay, I'm going to equate this, since the value of E3 and E2 is known, with this. So I'm going to equate this. So therefore we can write, okay, we can write in this way, E3 minus E2 equals hc by lambda max. Therefore maximum wavelength or longest wavelength, okay, so this is the longest wavelength. So this is hc by E3 minus E2. So let's put the value. We know Planck's constant is 6.63 times 10 power minus 34 joules second, okay, so we have this, and speed of light is 3 times 10 power 8 meter per second divided by, okay, so we have E3 is minus 13.6, okay, electron volt. So we have this minus, so what we find, again we have E2, and E2 is minus 30, okay, this is 30.6 electron volt. Clear? Therefore we can write lambda max equals, when we find the product, okay, in the numerator, so we get 1.989 times 10 power, okay, minus 25, and we can see this cancels out, okay, this seconds cancels out, and we get joule meter, and at the denominator, okay, we get 17 electron volt, okay, and we have to change electron volt into joule. So we need to write in this way, 1.6 times 10 power minus 19 joule, okay, so we get this. So joule and joule cancels out. So when we find this, okay, we get maximum wavelength is 7.3, okay, 1 times 10 power minus 8 meter. So we have this, okay, so this is the maximum wavelength or the longest wavelength. So we have this. Now let us find the solution for C, from which atom the energy levels have been taken. And when we look into this energy level, then we can tell that this energy level or the given energy level in the question is not of the hydrogen. So this is not the energy level of the hydrogen. So I'm writing over here, okay, the given energy level, okay, the given energy level diagram is not for the hydrogen atom. So we have to determine the atom, okay. So we need to find the atom for which the energy level diagram, okay, given the question belongs, okay. So what we need to do, we need to find Z, okay, that is atomic number. We need to find Z in order to, okay, in order to determine the atom for the energy level belongs. So we have this. So we need to find Z, that is atomic number, okay. So Z is what? This is atomic number. So we need to find Z in order to determine the atom for which the energy level belongs. So we have this. Now we are going to use the concept of hydrogen like atom, okay. So we are going to use that, and we know for hydrogen like atom, okay, for hydrogen like atom, okay, we have this delta E, this equals 13.6 electron volt, okay, times Z square times 1 by NF square minus 1 by Ni square, okay. So we have this. Now in order to find Z, okay, we can take any transition in this given energy level diagram. So let us take transition from n equals 3 to n equals 2, okay. So let me draw the energy level diagram first, okay, so that it will be more clear, okay. So we have this given in the question, okay. This is n equals 1, this is n equals 2, this is n equals 3, and we know E1 equals minus, okay. So E1 equals minus 122.4 electron volt, E2 equals minus 30.6 electron volt, and E3 equals minus 13.6 electron volt, okay. So as I said earlier, we can take any transition, okay, in this given energy level diagram, but for simplicity, okay, let us consider this transition, that is transition from n equals 3 to n equals 2, okay. So we are taking this transition. So we are taking this transition. So I'm writing over here, considered, okay, consider transition, consider transition from n equals 3 to n equals 2. So what we find in this case is that, okay, NF equals 2. So we have this, and Ni equals 3, okay. This is for initial and this is for final, okay. So we need to note this. Now we are going to use this equation. So we are going to use this equation, okay, to find Z in order to determine the atom, okay, for which this energy level belongs, okay. So delta E, so this is E3 minus E2, okay. Therefore, we can write E3 minus E2 equals 13.6 electron volt times Z square, okay. So we have this times 1 by NF. NF is 2 and 2 power 2 minus 1 by Ni. Ni is 3 and 3 power 2. So E3 is minus 13.6 electron volt minus E2 is minus 30.6 electron volt. So we have 13.6 electron volt times Z square, okay, and let us find this. So we have 1 by 4 minus 1 by 9. So we have this. Now let us find the left hand side of this relation, okay. So on simplification we get 17 electron volt. So this is 17 electron volt, okay. So we are getting, when we simplify this, we get this, okay, and we have 13.6 electron volt on right hand side, Z square, okay. Now let us simplify the term inside the bracket, okay. So we have this, so we get this, okay, and electron volt on both sides cancels out. So on simplification we can write 17 divided by 13.6, okay, this equals Z square, and we have 5 divided by 36. So we have this. Now let us find Z, okay. So before that, let us do some simplification. So we have 17 times 36, okay, divided by 13.6 times 5. So we get this, okay, after simplification 9. Therefore we have Z equals under root 9. So Z equals 3. So we are getting this. So what we are getting? We are getting atomic number, okay, Z equals 3. So it mean, okay, Z equals 3 corresponds to lithium, okay. So Z equals 3 corresponds to lithium. So the given energy level diagram, okay. So the given energy level diagram is of lithium. This is of lithium atom.